Okay, this is lesson 9.1. Not an official 9.1, kind of like before. This is a topic that is useful for the AP preparation, but it's not necessarily introduced in our textbook. So we're borrowing this 9.1 from a different textbook to supplement this. All right. So it's when you have these situations where if you take a quick look and see that you have these integrals that you really use direct u sub, because what is in your square root doesn't really have the du on the outside. So it's really not a straightforward u substitution. Therefore, we're going to utilize some trig functions to help us. Right. So the first scenario here is when your x is being subtracted. So you have a perfect square minus an x squared. Right. So it says let x equals a sine theta. So the idea here is that if you have a equals sine theta, you have a squared if you let x equals a sine theta, you have a squared minus sine squared theta within your square root. You're now able to factor out a squared, so you get 1 minus sine squared theta. And then don't forget, because of Pythagorean theorem, that becomes cosine squared theta, and hence this cleans up to be a cosine theta. Right. So again, the idea is using the Pythagorean theorem here, that sine squared theta plus cosine squared theta equals 1. So that is going to be the useful one for us. Okay. The next scenario is when you have a plus. That's much easier, actually. So it's a plus, it's always a tangent, right? So same idea here. You have a squared. You're going to replace the x with a squared tangent squared theta. Factor out the a squared, you get 1 plus tangent squared theta. And based on what we know from the Pythagorean identity here, that 1 plus tangent squared theta actually converts into secant squared theta, and this becomes a secant theta. Right. Lastly, if your x is positive and subtracting perfect square, now you want to set up your x as a secant theta. So you now have a squared secant squared theta minus a squared. Factor out the a squared, you get secant squared theta minus 1. And that will conveniently transform into tangent squared theta, and this cleans up into a tangent theta. Okay, so with these three types, you should be able to work out these trig substitution problems. Okay, all right. So in our first case here, I see that, okay, I have 4 minus x squared. So since the x is being subtracted, then this is going to be a situation where x is equal to the square root of this coefficient here times sine theta. So x equals 2 sine theta. Keep in mind, because you're trying to substitute, right now you're transforming everything that was an x into a theta, you need to also transform the dx. Therefore, after setting up x equals 2 sine theta, you need to take the derivative. So dx equals 2 cosine theta d theta. Okay, now let's replace everything I see here. I have 1 over x squared, so that actually becomes 4 sine squared theta, right? And then you have, not 4, sorry. Oh yeah, it's 4. So, and then you take square root, 4 minus x squared. X squared is 4 sine squared theta, right? And then don't forget your dx. So your dx is going to be 2 cosine theta d theta. Okay? All right, so you should clean up. So you get 1 over 4 sine squared theta. The square root now becomes 4 times 1 minus sine squared theta times 2 cosine theta d theta. Again, if you already know that 1 minus sine squared theta is going to turn to cosine squared theta, beautiful. So this becomes cosine squared theta, and it will clean up. So you can actually go ahead and kind of skip a step and go 4 sine squared theta. You get cosine theta here. I'm sorry, 2 cosine theta, because square root of 4 is 2. 2 cosine theta. You have 2 cosine theta up here, d theta. And yes, you can reduce that out because these two terms should be completely reduced out. Okay, so now your equation now becomes 1 over 4 sine squared theta. That's not super useful for us. However, we remember this is a reciprocal problem. So this is actually 1/4 cosecant squared theta d theta. Now this is something that we can do to take the antiderivative of. So then when we take the integral, we get negative 1/4 cotangent theta plus c. Okay, now you're not done, because this antiderivative is complete. However, it is in terms of theta. That's not useful for me. I want to change it back into x. So I got to go back to my original setup here. X equals 2 sine theta. So off to the side, you go x equals 2 sine theta. If you solve for theta, you get x over 2 equals sine theta. Reminding yourself that that relationship in a right triangle, that would be opposite over hypotenuse. So if you draw your triangle out, you get opposite over hypotenuse. Using Pythagorean theorem, you should be able to get that missing side to be 4 minus x squared. And typically that missing side should match what you started out with in your original integral. So you see the 4 minus x squared. Okay, now we need to plug that back into my final answer. So negative 1/4 cotangent. Cotangent is adjacent over opposite. So then that would be adjacent 4 minus x squared over opposite x. And then you have your plus c. And that would be your final answer. Okay? All right. Second one here, you have 1 over square root of 4 plus x squared. Because I see the plus, I know this is a tangent setup. So then my x is equal to 2 tangent theta. Same as before, I am going to go ahead and I'm going to go ahead and take the derivative of this so that I can figure out the replacement of dx, right? So I'm going to go ahead and replace this. Sorry, not replace. I'm going to take the derivative. So I get dx equals 2 secant squared theta d theta. Okay, so once you have the dx set up here, now I'm ready to go ahead and substitute this back in, right? So this is a trig substitution. So I get 1 over 4 plus x squared. So that's 4 tangent squared theta. And then dx gets replaced by 2 secant squared theta d theta. Okay, so now you have 1 over, so that 4 plus 4 tangent squared theta is 4 times 1 plus tangent squared theta. That's 4 times secant squared theta. So if you take the square root, you get 2 secant theta, right? Okay, and then don't forget you have your secant squared theta from the dx. So you have 2 secant squared theta d theta. Okay, reduce the 2's, reduce the secant. So actually your integral is very nice. It's just secant theta d theta. Now recall that secant theta has a very unique integral. So you can actually remind yourself of a trick, or you can memorize this. But the trick is to multiply top and bottom by secant plus tangent over secant plus tangent. So you can set up the u substitution with the denominator, and then it becomes du over u, which then makes this integral natural log of secant theta plus tangent theta plus c. Okay. Now, same as before, we can't leave our answer like this. So I gotta use my setup of x equals 2 tangent theta, x over 2 equals tangent theta, and go ahead and make my triangle. So make my triangle, see the relationship. So I got opposite over adjacent. So Pythagorean theorem will be x squared plus 4 square root of that. Okay, now I can go ahead and plug in. I get natural log of secant. Secant is 1 over cosine, so that would be adjacent over hypotenuse. So it would be adjacent over hypotenuse, okay? And then plus tangent. Tangent is opposite over adjacent, so opposite over adjacent. And then plus c, okay? And that's your final answer. All right, last one here, we have the situation where you have x squared minus 9. So it is a secant situation here. So you have x equals 3 secant theta, right? It's the square root of that coefficient there. So that constant there, sorry. All right, so go ahead and take the derivative. If dx equals 3 secant tangent d theta, okay? All right, now I'm ready to plug in. Let's see what my result will be. I get x squared, not x squared, sorry. I get my 9 secant squared theta minus 9 all over, what is x? X is 3 secant theta, and dx is 3 secant theta tangent theta d theta. Okay, I can clean this up already, right? I can clean up 3 secant is gone. Okay, I also know then that the top will clean up to be 3 tangent theta based on what we did here, right? So 3 tangent theta times tangent theta d theta. So that will give me 3 tangent squared theta d theta. Now remind yourself that tangent squared theta can be rewritten, right? Tangent squared theta is really secant squared minus 1. So because this is not an antiderivative we can do, so we're going to use the identity to convert. And I will pull the 3 outside, and I get secant squared theta minus 1 d theta. Okay, now I can take the antiderivative. I get 3 tangent theta minus theta plus c. Okay, once I take the antiderivative, don't forget to draw your triangle. So I go back and say x equals 3 secant theta. X over 3 equals secant theta. So I draw a triangle. Secant is 1 over cosine, so that will be hypotenuse over adjacent. So hypotenuse over adjacent. So then my Pythagorean theorem will be something plus 9 equals x squared. X squared minus 9 square root will be my missing part, right? Missing side. All right, now I'm ready to put this in. Tangent would be opposite over adjacent. So opposite x squared minus 9 over 3. And here's where it's a little bit different. What is theta? Well, theta is the secant inverse of x over 3. That's okay, that's valid. And then plus c. Okay? All right, please make sure you complete this homework assignment for this section so you are well versed in these trig substitution. Okay? That's it, guys.